You know, when you think of an engineer, you probably picture someone in a hard hat, right? Designing a bridge or a skyscraper. But what if the greatest, most impactful engineers on our planet actually live in the ocean and weigh over 40 tons? Well, in this explainer, we're going to dive deep into how whales are these surprising and absolutely vital architects of the sea.
To really get this, we have to start with a pretty challenging question. What if the ocean we've all been studying for the last 100 years isn't the real ocean? What if it's been missing its most important players this whole time? Because, well, that's exactly the situation. When modern oceanography really kicked off, we were looking at an ecosystem that was profoundly empty. Up to 90% of its biggest, most influential animals, the great whales, were just gone. Our entire baseline for what a normal ocean looks like was based on a shadow of its former self.
So, how on earth did this happen? To understand how the ocean lost its giants, we've got to look back at a history of hunting that spans an entire millennium.
It actually started 1,000 years ago with Basque hunters targeting right whales in the Atlantic. But it was the 20th century that brought just industrial-scale devastation. New technologies, like these massive factory ships, allowed for relentless, non-stop hunting. And whale populations that had been around for millennia were pushed right to the brink in just a few decades, which finally, thankfully, led to the 1986 moratorium.
And that brings us to this number, 90%. Just let that sink in for a second. The scale of this loss is almost impossible to wrap your head around. Some genetic studies suggest it was at least this high, if not higher. We didn't just remove a few animals, we functionally erased an entire ecological force from the planet.
And this chart right here, it shows you exactly what we lost. See, it wasn't just the animals themselves, it was the critical jobs they performed. Just look at that drop in the bars. They represent two incredible processes we're about to get into, the whale pump and whale falls. Before industrial whaling, their effect on the ocean was massive. Today, it's a tiny, tiny fraction of what it once was.
So this brings us right back to our central idea. If we want to understand what a truly healthy ocean is supposed to look like, we have to study the original blueprint. And in that blueprint, whales were the chief engineers.
Now, the scientific term for this is an ecosystem engineer. It's any species that actively shapes its environment. Think of beavers building dams or corals building reefs. Whales do the exact same thing, but on an oceanic scale. And it all starts with a surprisingly simple process that has a gigantic impact.
It's called the whale pump. And honestly, it is an elegant and powerful cycle. Whales dive deep to feed on krill and fish, which are packed with essential nutrients like iron and nitrogen. Then, they come back up to the surface to breathe and, well, they poop. They release these enormous fecal plumes that act like fertilizer bombs in the sunlit surface waters, sparking huge blooms of phytoplankton. And phytoplankton, they're the tiny plants that form the absolute foundation of the entire marine food web.
Removing the whales also triggered this shocking chain reaction, what scientists call a trophic cascade. With their main food source, great whale calves, suddenly gone, some killer whales had to switch their diet. They started hunting smaller prey, like sea otters. So sea otter populations crashed. And with no otters to eat them, sea urchin populations exploded. And what do sea urchins eat? Kelp. They mowed down entire coastal kelp forests, totally destroying these vital habitats. The absence of whales literally reshaped coastlines. It's an unbelievable domino effect.
But perhaps the most profound, most incredible role whales play comes at the very end of their lives. It's a process that creates an entire oasis in what is essentially a deep-sea desert.
This is a whale fall. When a whale dies, its massive body sinks miles down, delivering this huge pulse of nutrients to the deep-sea floor, an environment that is often called an ocean desert because food down there is just so incredibly scarce. Okay, get ready for this because the scale of this delivery is truly mind-bending. A single 40-ton whale carcass delivers the same amount of organic carbon to that one patch of seafloor as would normally arrive over 2,000 years from that slow drift of what we call marine snow. I mean, can you imagine 2,000 years of food delivered all at once? It is an absolute jackpot for the deep sea. And this jackpot doesn't just feed a few animals. It creates a unique, long-lasting ecosystem that unfolds in stages. First, the mobile scavengers like sharks and hagfish arrive for the feast. Then, a whole host of opportunists colonizes the bones and the surrounding sediment. And finally, for up to a century, specialized bacteria break down the fats inside the bones, producing sulfur compounds that support a whole chemosynthetic community, a world of life that thrives without a single ray of sunlight.
This is why scientists believe whale falls aren't just isolated islands of life, they are stepping stones. They act like bridges, connecting other deep-sea oases like hydrothermal vents and cold seeps. By forming these links, whales literally connect and enable entire deep-sea ecosystems across the vast, dark floor of the ocean.
So, what does all of this mean for the future? As we work to protect whales, we're not just saving a charismatic species. We are trying to restart a global engine.
So let's just put it all together. The official job description of an ocean engineer includes enhancing productivity with the whale pump, boosting biodiversity with whale fall habitats, and, get this, regulating the climate by locking away huge amounts of carbon in the deep sea for centuries. These aren't just little side effects, these are invaluable services for a healthy planet.
Now, the good news is that some whale populations are making a real comeback. North Pacific humpbacks, for example, are showing really strong recovery. But the fight is far from over. Species like the North Atlantic right whale are teetering on the verge of extinction. And all whales face a gauntlet of modern threats, from ship strikes and getting tangled in fishing gear to pervasive, stressful ocean noise.
And this all brings us to a final, really hopeful thought. All we did was remove the harpoons. That's it. And in doing so, we gave the ocean's greatest engineers a chance to get back to work. So now, as they slowly return, fertilizing the seas, shaping food webs, and creating new life in the deep, are we witnessing the ocean beginning to put itself back together? It's a powerful reminder that sometimes the best way to fix a broken planet is to simply get out of the way and let its best engineers do their job.